To summarize what we have discussed, for the traveling sinusoidal wave, the traveling sinusoidal wave the functional form of the traveling sinusoidal wave can be written as a sine kx minus omega t. Please note that we can also use the cosine function here too, so it depends. The physical meaning of the parameters is that A is the amplitude of the oscillation. K is the wave vector, wave number. That is K is equal to the 2 pi over lambda. Lambda is the wavelength of the wave, and omega is the angular frequency. The angular frequency omega is equal to the 2 pi over t, where this big T is the period of the oscillation of the medium. Now, if we go back to the original functional form of the wave function, we can also write the wave function as a sine k of x minus omega over k of t, like this. And if we compare with the general functional form of the traveling wave, the general functional form of the traveling wave is that y xt is equal to the f of x minus vt. Note that we are talking about the wave that moves in the positive x direction, so we have the minus sign here. And if you compare these two expressions, it is obvious that if we say that the functional form is the a sine of k, something like this. So the argument of this function is x minus omega over kt. Compared to this equation, so we have the velocity, of the wave is v is equal to the omega over k. Okay. But if we substitute the value of omega here and the value of k here, so we have that this is 2 pi over t times lambda over k, lambda over 2 pi. So you can see that these 2 pi cancel, and we have that v is equal to the lambda over t. But the reciprocal of the period is the frequency, so this is equal to the lambda f. Okay, so from the expression of the sinusoidal traveling wave, we have this relation that the velocity of the wave is equal to the product of the wavelength lambda and the frequency f. Okay, so if we know the frequency of the oscillation of the wave and the wavelength lambda, we can calculate the velocity of the wave v equal to the lambda f like this. From this calculation, we may finally write down the wave function of the traveling sinusoidal wave as yxt equal to the a sine 2 pi over lambda, which is k here, times x minus vt. Okay, here v is omega over k here. This is not the most general expression of the sinusoidal traveling wave. You can see that at this, if you use this equation at the point x equal to 0, at the time t equal to 0, y is equal to 0. But we can observe or take a snapshot of the wave at any time. So to make this equation more general, we can use the same concept as when we explain the oscillatory motion, that the more general form of the traveling sinusoidal wave is a sine 2 pi over lambda of x minus vt plus phi. This phi is a phase constant, and it has the same law as the phase constant in the oscillatory motion. It means that this value of phi will determine the displacement of the medium at time t equal to 0 at the position x equal to 0. Okay, so we may say that this is the most general form of the mathematical, of the functional form of the traveling sinusoidal wave.